So, just to finish off the transition elements, we need to look at redox reactions and transition elements. You need to know these because sometimes I'll ask you to give examples of redox reactions, and it helps just to know a few that you can reel off in your answers. So, one could be taking, so examples. Now we've done lots of examples in the past which you'll be able to recall, but this will hopefully just help you. So one example would be taking bromine and reacting it with Fe2+ ions to give you bromide ions plus Fe3+ ions. It's quite an easy one to remember, like so. So what's our oxidation state of bromine here? Elemental bromine.
0.
0. Iron 2+.
2+.
Bromide.
Minus.
1, yeah, and iron 3+.
Plus 3.
So iron has been oxidised and bromine has been reduced. So I have got +2 here. I've got +3 there. Do I need to do some?
No, but you've got 2 bromide ions, so you've got +1.
Yeah, but I'm still lacking something, aren't I? I need. Oh, you're right. Okay. Do I need a bromide? I need 2 of those and 3 of those.
Is that the next bit?
No, that can't be right. What am I doing? Okay. No, I can't have 2. I need 2 of those, don't I?
Get back to the one.
Oh, so that's +4. That makes it work, yeah. +4, yeah.
So bromine has gone from 0 to -1, so it's reduced.
Yep, so let's add it on. He has been reduced and he has been oxidized. And then we've got one which you probably, it's just a metal displacement reaction. You take zinc, where's no excuse, and iron 3+, and you're going to make zinc 2+, and iron 2+. Works, doesn't it? So it's nice, actually. It's just an oxidation. So iron has been reduced and zinc has been oxidized.
What's the state symbol of zinc?
Okay, zinc is going to be aqueous, 2+, iron 2+ is also aqueous. Okay, so one really exciting example is a disproportionation reaction of copper plus. So an example of a disproportionation reaction is copper plus aqueous disproportionates to give you copper metal and copper 2+.
Is there meant to be an R after the P, or is it dispo wash?
Dispro.
Only
no.
Dispor.
I think it's pro.
Okay,
You can use that on pro, it's okay.
who else is
Okay.
English here? Just me.
Who else is English?
No.
Okay, so
English.
this tells you that copper is very unstable in aqueous solution. So copper plus is unstable in aqueous solution. If you put copper plus in water, it doesn't stick around. It becomes copper metal and copper 2+. So what would you see happening? You'd see a metallic precipitate, and you'd also, what colour would the solution go?
Blue.
Blue. So So you see a precipitate. Copper metal is kind of like a red-brown colour.
Oh, and you've got the coins.
Yep. And then a blue solution. What colour will copper plus be?
Colourless because it's not a transition metal.
And where it's not, it hasn't got a full, it's got a full D subshell. So that would be brilliant, yeah, that would be colourless.
It's quite good, wasn't it?
Yeah.
Because it's got a D10. It hasn't got a partially filled doser.
Well done.